Okay, we're having people starting to trickle back in. Let's go ahead and get started on the second session of VIS4DH. So people are trickling in now. By the way, for the keynote, there will be some interactive exercises. That's the reason for the pens and the paper. So there will be some video presentations a little later on that include sound, and you'll be prompted to draw on the paper as a part of that. So that should be fun. If you don't have a piece of paper or a pen, Eric has it in the back there. And I'm not sure how many pieces of paper might be needed. Hopefully we have enough for that. Okay, well, so I'd like to welcome Ed Summers. This should be very interesting for us because Ed is blind. I don't know about you, but I've been very interested in multimodality and cross-modality perception for a long time, and it's not something that we get very much of in visualization proper, that we don't talk about very much, even though auditory display, sonification, and so on are fields that people do study that are in many ways parallel to the kinds of work that we do in visualization. So I, for one, am really looking forward to this keynote. To introduce Ed Summers, he's the former head of accessibility at SAS and is currently the head of accessibility at GitHub. And his personal mission is to empower people with disabilities to realize their full potential in the classroom and the 21st century knowledge economy. Right, so to be more inclusive in terms of the tools and the capabilities that we provide through computation. So with that, Ed, please take it away.
Thank you, Chris. Thank you so much. And thank you to VIS4DH and the organizing committee for inviting me to be with you this morning. It is an honor to be, I think, the first person with blindness to keynote at this conference. And I don't take it lightly. I'm absolutely thrilled to be here and spend some time with you. Before we get started, for those of you both in the room and listening from home, Chris mentioned paper and pencil. And so grab those if you have them available. We'll need them in just a minute. And also, if you're listening from home, grab headphones. If you have headphones or earbuds, that might we're going to use some stereo panning technology, and that might, it'll enhance the experience, not required. And the paper and pencil is also not absolutely required. It'll just make the activity a lot more fun and engaging. So my formal education is in the fields of math and computer science. I worked as a software engineer for about 10 years after school, and I've been managing technical teams and programs at software companies for about the last 20 years. I've spent the majority of my professional career at SAS, as mentioned. At SAS, I built and managed the accessibility program started in 2010 through August of this year when I took an opportunity at GitHub. But during my time at SAS, we spent a lot of time working on the accessibility of data visualization. And my colleagues and I made some significant advances in the field and shipped software that enabled people with blindness to perceive data visualization like it was simply not possible to do before. So I want to lay on top of that history my lived experience as a person with blindness. When I was 10 years old, I was diagnosed with a degenerative retinal disease called retinitis pigmentosa. I lost vision very slowly at first, but in my mid-20s, the rate of loss of visual loss increased significantly. And I was pretty much functionally blind by the time I was in my mid-30s. So the title of this talk is A Path Towards Inclusive Visualization. As you can guess, the people who are excluded are people with blindness and, to varying degrees, people with low vision. From this point forward, I'll refer to this entire population as just people with visual impairments. So how does the technology that we refer to as visualization exclude people with visual impairments? Well, first, as the name suggests, it is inherently visual, and it's primarily focused on the visual mode of perception. However, there are other modes of perception that are used by people with visual impairments to perceive graphical information. And we'll talk more about those modes momentarily. Second, as a general rule, the systems that are used to create and distribute visualizations also don't support these other modes of perception. So one example is the authoring tools and libraries that are used to create visualizations. And another example are the standards and technologies that are used to share visualizations on the web. Now, I'm speaking in generalities here. There are some exceptions where authoring tools and we've managed to make multiple modes of modality, kind of push them through the existing standards and web technologies, but those are by far the exception and not the rule. But as a result, it is very difficult for kind of the general visualization professional to, even if they want to, it's difficult for them to create and share visualizations that are inclusive. Okay, so here's the key point. If you take nothing else away from this presentation, the key point is this. I call on you, the visualization community, to do your part to make visualization inclusive from this point forward. So how can you do that? I'll offer a few suggestions, but of course there's a lot of work to do here from a lot of different parties. So I'll just offer a few that I think might be most relevant for this population. First, I encourage you to hire or collaborate with people with visual impairments. If you have a lab or if you have project funding, I encourage you to recruit people with visual impairments to contribute. Doing so will give you the opportunity to learn about the tools and the technologies that we use to access computers and information. In addition, of course, people with visual impairments we deserve to be able to contribute to any profession. And particularly if you are interested in making visualization more inclusive, we have much to share. We have a saying in the disability community that is nothing about us without us, nothing about us without us. And that reflects the fact that we are smart, we are capable, and some of us are very highly motivated to remove barriers to access. Second, as you write project proposals and project plans in the future, I want to encourage you to include accessibility and inclusivity as part of the plan. As you do that, recruit collaborators that have experience making visualizations accessible using non-visual modalities. There's a growing number of us out there. And if nothing else, doing so will be a learning experience for everyone involved. My third and final suggestion is to expand this wonderful community of IEEE VIS to include both researchers and practitioners of non-visual modalities. I commend you. It is simply amazing that you've made the theme of this workshop multiple modalities. That's absolutely wonderful. And I think a wonderful next step would be to bring multimodalities and non-visual modalities into the main conference on a regular basis as a mainstay. So what are those non-visual modes of perception that are currently used by people with visual impairments to perceive graphical information? There are two that are currently used widely. The first one is the tactile mode, which is made possible by tactile graphics. And the second one is the auditory mode, which is made possible by sonification. So both tactile graphics and sonification have their strengths and weaknesses. Neither one is categorically better than the other. But I have extensive experience with the field of sonification, so I'm going to just give you a brief overview of tactile graphics and a reference, and then we'll move on to do a deep dive on sonification. So tactile graphics are born out of and commonly used with Braille. As you know, Braille is a system of raised dots that enables people with visual impairments to perceive the Braille characters and then we translate them into text. Similarly, tactile graphics use raised lines and shapes to convey the elements within a tactile graphic. And of course, any of the text labels within a tactile graphic are typically written in Braille. Tactile graphics are generally created by hand or using some different systems of mass production, probably the most common of which is called a tactile graphics embosser. Now, one key point to know, probably the most important point for this audience to know about tactile graphics, is that tactile acuity is significantly less than visual acuity. As a result, visualizations do not transfer directly from the visual medium to the tactile medium. Another key point is that tactile graphics are not interactive. Typically, they're printed on paper or other some kind of physical medium like that. But there are several research teams that are working on refreshable tactile graphics displays. Some prototypes of these displays can support zooming and panning and features like drill down. Unfortunately, though, at this point, the manufacturing costs of tactile graphics displays is still too high to support widespread adoption. For more information on tactile graphics, I'll refer you to the BANA guidelines and standards on tactile graphics. BANA stands for Braille Authority of North America, BANA. And you can find more information on those guidelines and standards at brailleauthority.org, brailleauthority.org. All right, let's move on to sonification. I started working on accessible data visualization in 2011. And after some initial research, I chose to focus our investments at SAS on sonification because I felt like it was the most promising technology for getting working solutions into the hands of people with visual impairments. And rather than tell you about sonification, I'm going to show you and I'm going to teach you how to use it in a rudimentary way. And we'll do some activities. And my goal is for this to be an existence proof of an effective non-visual modality for visualization. So bear with me just one moment as I share my screen here. All right.
Stop share. Alt+S button.
Okay.
The video thumbnails are minimized to optimize full screen video clip screen sharing.
Okay, at this point,
Desktop list. Zoom 12 of 12.
you should be seeing my desktop, and you should be
Participants
hearing,
now see your screen alert.
you should hear
News for 11 of 12.
some speech that is very fast. And I wanted to start with my desktop here because I want to just point out some of the interaction model that is native for those of us who are blind. So we use these programs called screen readers to access our computers. And the access, as a general rule, the access is completely based on the keyboard. There are some exceptions to that, but as a general, that's true. And also, as a general rule, our output mode is text to speech, so computer generated speech. And again, there are some exceptions to that as well. But I'm just speaking in generalities here. So I'm just going to use my arrow keys to
Microsoft Edge 10 of 12.
navigate around
News for 11 of 12. Zoom 12 of
the
12.
screen. You should be able to see a little highlight there moving
Power BI desktop set. Adobe Acrobat 2 of 12.
up and down on the icons there. And as I'm doing so, I'm hearing speech in my ear here that is pretty fast. So those of us who are blind, typically we speed up the rate of our speech to, well, I know some people who are up around that 700 words per minute range. People who are blind, congenitally blind, so blind since birth, tend to, in my experience, anecdotal evidence, they tend to boost that rate much faster. The rate you're hearing right there, which probably sounds like a chipmunk, is probably around 2,500 and 600 words per minute. So let's say 3 or 4 times faster than normal speech, and probably about twice as fast as what your typical college graduate reads with their eyes, print with their eyes. Yeah, Chris?
Yeah, we're seeing your main regular desktop. Do you mean to be showing a different screen?
Yep, I was just showing my desktop here. Thank you,
Okay.
Chris. Yeah, I was just showing my desktop just to kind of
Power BI desktop. Zoom 12.
to explain some of the basics of a screen reader.
Okay.
Yeah, but now let's move on to sonification.
Okay, very good. I'll just try to make sure that it seems like we're seeing what you want us to see.
No, that's so helpful because I can't see my screen. So yeah, it's great. Thank you for providing the backstop. So now you should be seeing, let's see, and bring this up.
Script docs were 1, 1. Spotify Premium 1, 2. Zoom 1, 3. Sample 1, 4. Graph view. SAS graphics accelerator Google Chrome 1, Graph view. SAS graphics accelerator Google Chrome. Explore mode. Application.
All right, now
System menu. Application.
you should see kind of a white on black display in Chrome. Okay.
Yes, that's correct.
Oh, great. Thanks, Chris. Okay, so when we think about sonification, I want you to think about the palette that we can use for sonification. In this case, we're looking at a palette that is our Cartesian plane, which many graphs, are bar charts, line charts, scatter plots, things like that, are represented, of course, on a Cartesian plane. There are other forms that we won't get to, but we're just going to keep it really simple here to introduce some of these basics. You should see the rectangle on my screen that represents the Cartesian plane. And over the next couple minutes, I'm just going to give you an idea of some of the bread and butter features that are widely used in sonification applications. Now, when we map data to sound, typically we have to use and assign some audio characteristics and assign meaning to those characteristics. It is very common to map pitch to the y-axis, so the differences in pitch. And it's also very common to map the x-axis to pan between left and right speakers. And that's what I've done here. And I'm going to just show you really quickly. Okay. So that sound right there, you should be hearing completely in your right ear. If you are, it's on the right side of the screen. And this sound over here, you should be hearing in your left ear. It's completely 100% in your left ear. And it's pretty common for people to have their earbuds reversed or to have their speakers plugged in backwards. So if that's the case, then I want to encourage you to fix that really fast so that you can follow along. So again, right as a test and left. Okay, and if you're in the room there in Oklahoma, I expect that you are probably hearing this in mono. So you probably will be hearing no difference. So that's right, and again, that's left. All right, so we're done with that test. Now, as far as pitch goes, so those sounds map to our x-axis, and we can play sound all the way across here. Well, at least, right, so that you should have heard that. If you have your headphones in, you should hear that move from your left ear gradually over to your right ear, right? And then let's go back kind of towards the center. And then we can also jump down to the bottom. So we've mapped pitch to our y-axis. And at the bottom, that means it's a very low sound. And at the top, it's a very high sound. So basically this pitch here, we're playing piano keys that are essentially mapped to the piano keyboard. All 88 keys are not present. It's kind of a sampling of those. But if you were to take a piano and you were to kind of stretch out your right hand, put your right hand underneath the keys and flip it up so it's standing on its end, then that's kind of, you can think about, those are the bends that we have here as we move down y-axis. It keeps going. All right, there it is. And there's a little sound there. Oh, okay, we're at the end. That's what that little sound means. Okay, now, so let's do the circumnavigate our palette here. And this is the palette upon which, or the display, I guess, that we're going to paint visualizations, okay? So let's go over here to the far left. And I'm going to switch modes.
Scan mode.
Okay, and let's go all the way across the bottom. And let's go up the right-hand side. Okay, let's go all the way across the top from right to left. And let's go down the left-hand side from top to bottom. Okay. All right, so that's our acoustic palette. And of course, you should be able to see this really high contrast display here that is really optimized for people with very low visions, let's say 2200, which is legal blindness here in the US, or worse. And there's a whole range of different types of visual impairments. This kind of default visual display here was set up to kind of find a sweet spot for the majority of those types of visual impairments, the majority of types of low vision. Okay, now let me introduce a little trick here. I'm going to hide my screen.
Temporary screen curtain. Enable until next restart.
Okay, so now I've turned on a screen curtain. Screen curtains are very common in screen readers. One of the things it does is it provides privacy for those of us with visual impairments if we're taking a test or something like that, or entering bank information or whatever, that kind of thing. And it also is very handy for presentations like this, so that I can kind of give you a visual impairment, right? That's really what I'm doing, is giving you a visual impairment. So I want to jump over to some very simple sample graphs that I want to show you, and just give me one moment to navigate over and stand by.
V. Results. Program 1 Google Chrome. Results. Program 1 document. Button accelerated HG plot procedure. SAS graphic.
All right.
Script docs word 1 column 2. Spotify premium 1 column 4. Samples 1 column 5. Samples window. Items view list.
Okay.
2 basic personification.html. 120x35.html 117. 2 basic personification.html 2. Sample line charts Google Chrome. Sample line charts. Accelerate sample line charts button. Graph view. SAS graphics accelerated Google Chrome. Graph view. SAS graphic.
Okay. All right, so here we are. I'm going to play a simple sample graph for you, and then I'm going to reveal it to you. And the idea here is that I want to kind of quickly teach you how to perceive graphs, line graphs, and bar graphs using sonification. So we get to the right group.
Example 2. Example 1.
All right, let's go. Here we go. First one. There we go. Okay, I'll play that one more time. Okay, so if you have your pen and paper.
Ed May, but, sorry. We are seeing a blank dark screen with just your mouse pointer. We're supposed
That's
to be. Oh, that's correct?
Yep, I've
Okay.
turned on a screen curtain. Thank you, Chris. Yeah, I turned on a screen curtain to basically give the audience a visual impairment.
Got it.
So I'm taking
Okay.
the visual mode of perception away from you. And hopefully you're hearing the graph here. And I'll play it one more time, but I want you to, draw like a 4 by 2 inch circle, or a 3 by 3 inch circle, rectangle on your paper. And based on what we learned thus far, low pitches are at the bottom of the screen, high pitches are at the top of the screen, so pitch is mapped to the y-axis. Take a guess at and draw just a quick sketch of what this graph might look like. I'll play it one more time. Okay, and now I'm going to reveal my screen.
Screen curtain disabled.
And now let's take a look. Here we go. Play it one more time, just so you can see it with your eyes. Here we go. Okay, so that's basically x equals y. All right, and it goes from the bottom left to the top right. And you might just kind of, mark, put a 1 on that graph. We're going to do a bunch of these. And let's go look at the next one and see if you can hear what the next one is. So I'll go and I'll disable my screen.
Temporary screen curtain. Enable until next restart.
All right, and now let's go find the next one.
All groups. Example 7. Example 6. Example 5.
Let's see what this one does. Here we go. Ready? this is number 2. So you should have just heard that. The screen should be blank so that you can't see it. I'll play it one more time. All right, now this one's deceptively tricky. I'm going to enable my screen, and you should be drawing this, right? So draw a little rectangle on your paper, and then try to draw a quick little sketch, just a quick little sketch about what the slope of this line is. Now I'm going to reveal so you can see it.
Screen curtain disabled.
All right, so now you should be able to see my screen, and I'll play it one more time. All right, so this is just y equals a constant, and that constant is should be roughly in the middle of the screen, right there. That would be the hardest part about this. This one's deceptively hard because you have to figure out now what exactly, what is the range of sounds that I hear, and where does that particular tone fall on the y-axis? And the answer is kind of in the middle, good enough, right? All right, let's go for another one. I'm going to hide my screen.
Temporary screen curtain enabled until next restart.
All right, go find the next one.
Example 6.
All right, here we go. This is, for you guys, this will be number 3, and I'm going to play it so you can't see it. Here we go. All right, one more time. Okay, now for the big reveal.
Screen curtain disabled.
Here we go. I'll let you see it. All right, this is basically the inversion of y equals x. Supposed to start from top left to bottom right. All right, let's do one more here just for fun, and we will move on to more interesting things. Let's go hide my screen.
Temporary screen curtain enabled until next restart.
And
Example 7. Example 1. Example 2.
all right, here we go. Let's try this one. This one's more difficult. Here we go. You should not be able to see my screen, and I'm going to play it for you. All right, play it for you one more time. This one's harder. You should be drawing this now in a little box on your piece of paper. And now I'm going to reveal so you can see what it really looks like.
Screen curtain disabled.
There we go. Okay, so that's obviously a sine wave. All right, so now let's move on to some more interesting real world examples. So you do a quick time check.
12:17 p.m.
12:17. So we're about what, 30 minutes in. Okay, that's great. Hide my screen.
Temporary screen curtain enabled until next restart.
Okay. All right.
Sample line charts document. Button accelerate sample line charts.
And let's go over here.
SAS graphics accelerate. Sample 01 column 2. Sample window. Item view list. 2 bit. 3 historical line chart showing U.S. population 1,842,010.html 3 of 17. Line chart showing U.S. population 1,842,010 Google Chrome. Line chart showing U.S. population 1,842,010.
Okay.
Accelerate line chart showing U.S. population 1,800. Graph view. SAS graphics accelerator.
Okay. Now this is more of a real world example. This is real data. And I'm not going to tell you what the data is. I'll tell you what that is when I reveal what the graph is. But here we go. I'm going to play it from left to right, as usual. And draw a little rectangle on your page. And let's see if you can get this one right. This is real data. All right, now I'm going to reveal, and you should be drawing this. Here's the reveal.
Screen curtain disabled.
Okay, so what you're seeing here, this is the U.S. population from 1840 to 2010, I think, if I got that right. All right, I'll play it one more time for you just so you can see it. now let's go. We're going to hide my screen again.
Temporary screen curtain. Enable until next restart. Line chart showing U.S. population 1,000.
Let's go see. We'll look at a related graph. Same time period, where each step on the x-axis is a decade, from 1840 to 2010. And let's see.
No next button. Graphic line chart showing U.S. population 1,000. SAS graphic set. Samples window. 44.2 line chart showing U.S. employment in agriculture 1,842 2010 by HTML 417.
Okay. Here we go.
Line chart showing U.S. employment in agriculture. Accelerate line chart showing U.S. employment in agriculture. Graph view. SAS graphics accelerated Google Chrome.
Here we go. Same time period, different data. Oops, I think I'm going to cut that off earlier. All right, play it one more time. Okay, now let's reveal it.
Screen curtain disabled.
Here we go. Yeah, so this is the percentage of people that are employed in agriculture by decade between 1840 and 2010. Play it one more time. It's kind of flat there at the end. All righty. Got a couple more for you. And if there's a Discord, I think there is a Discord associated with this, feel free to drop in how you're doing. With these, if there's a social component to this, let's move on to the next one. I'll go hide my screen.
Temporary screen curtain. Enable until next restart.
All right.
Line chart showing U.S. employment in agriculture 1,842 2010. Button accelerate line chart showing U.S. employment in agriculture. SAS graphics accelerated customer product page 2. Samples window. Items view list. 4 historical 2 line chart showing. 5 historical 3 line chart showing U.S. GDP per capita 1,804. 6 historical line chart showing U.S. death rates. Group by HTML 617.
All right. This one's going to be a little bit more complicated. We're going to do some. We're going to keep making it more difficult as we go.
Group series block Google Chrome. Group series block. Graphic group series block. No next button. Graph view. SAS graphics accelerated Google Chrome. Graph view. SAS graphics accelerated document. Loading. Graph view.
All right. So you should not be able to hear my screen. And this graph, I'm not going to tell you exactly what it is, but the span is almost the entire 20th century, so from 1900 to I think 1998, and it's grouped. So there's multiple groups that we're going to display, or that we're going to listen to. And let's see. Let me go find the first.
Cancers.
Okay. All right. Here we go. Playing it from left to right. Oh, and I need to speed this one up a little bit because this one has what, 98, 100, almost 100 data points. And to play it at that rate, it gets kind of hard to hear the working memory there, to keep everything in working memory. So I found that it's a lot more effective to
slow, normal,
speed it up. So I'm going to speed it up a little bit so you can just kind of hear it faster and keep everything in working memory. So here we go. Okay, one more time. Okay, you should be drawing this on your paper. One more time. All right, and now let's reveal it.
Screen curtain disabled.
Okay, what you're going to hear, what you're hearing here, are these are death rates throughout the 20th century. From different causes, and what you just heard was cancer. So let's play it one more time here. And by the way, the y-axis is represented in deaths per 100,000. So you're seeing cancer here. All right, now let's go look at another one, and I'll tell you what it is before we play it. But I'm going to hide my screen, of course.
Temporary screen curtain. Enable until next restart.
All right.
Diabetes.
Okay, this one is diabetes. All right, so draw a new rectangle. Okay, now at the beginning over here, we heard something kind of weird. Let's go check this out. We heard these thumping sounds. Thumping sounds. These thumping sounds represent no data. So there's zero. It's zero. 0 per 100,000 here. And all right, so let's go back and play it again. Here we go. From the beginning, left to right. and then let's reveal so you can see it.
Screen curtain disabled.
Okay, one more time for you. All right, now let's move on to a couple more. We'll hit a couple more of these, and we'll wrap with some financial data.
Temporary screen curtain enabled until next restart.
Let's see.
Diarrheal disease. Heart disease. Pneumonia and influenza. Road accidents. Heart disease.
Okay. This is heart disease. Okay, you should not be able to see my screen. And let's play it again from left to right. All right. Again from left to right, heart disease. And you should be drawing this. All right, I'll do it one more time so you can just refine your sketch. All right, and now let's reveal it.
Screen curtain disabled.
Okay, one more time. I don't know about you, but I'm really happy that for the last 10 or 15 years there, it seems that heart disease is decreasing. That's pretty obvious. You can hear that very well. So let's go one last one here with death rates, and then we will switch over to some financial data.
Temporary screen curtain enabled until next restart.
Okay.
Pneumonia and influenza.
Okay, this one is pneumonia and influenza. Pneumonia and influenza. So let's play it. You should not be able to see my screen, and I'm going to play it from left to right. Draw a new rectangle on your paper for pneumonia and influenza. One more time. Okay, I'll play it one more time. Okay, this one's a little bit of a trick question. And if, you know, audio over Zoom is only so good. So I'm going to slow this down quite a bit and play it again because there's a particular feature here that I want to make sure that doesn't escape your attention just because of technical difficulty. So
Slow. Slowest.
this is the slowest setting. This will go kind of slow, but bear with me here. Okay, so I'm going to reveal this to you so that you can see how you did with this one. You should have been sketching it.
Screen curtain disabled.
All right, and then we'll play it again at that speed. Okay, so as you might be able to hear, there's a really high data point right there, and I'm going to switch over to a different mode
Explore mode.
so that I can kind of explore point by point and do some point estimation. So I'll go back to the beginning of the graph. This is, I think, the year 1900. Let me turn on speech here.
Cheers.
All right, I've turned on speech so that as I explore point by point, we can hear exactly what some of these values are.
1901, 100, and 97.2, pneumonia and influenza. 1902, 100, and 61.3, pneumonia and influenza. 1903, 100, and 69.3, pneumonia and
Let's
influenza.
go ahead a few.
1917, 100, and 64.5, pneumonia and influenza. 1918, 588.5, pneumonia and influenza.
1918.
1917, 100, and 64.5, pneumonia and influenza. 1918, 588.5, pneumonia and influenza. 1918, 588.5, pneumonia and influenza.
Yeah, 585 in 1918, and that was obviously the Spanish flu from 1918 is where that single data point was. And by the way, that is the highest data point by far in the entire data set. Okay, So, what have we covered here? We covered certainly the ability to perceive trend. We did just a little bit of point estimation, right? I'm going to wrap with one kind of current timely financial data set. But before I do, so we basically looked at the Cartesian plane. The kinds of graphs that would be represented would be line charts, bar charts, histograms, your basics, kind of bread and butter statistical analysis types of graphs. We've done quite a bit of work here in this product. This product is a free product called SAS Graphics Accelerator that we created for students and professionals with visual impairments to be able to perceive data, both independently and to be able to share them. This product, by the way, does, this extension, Chrome extension, does integrate with several SAS products, so to kind of extend some of the accessibility capabilities of SAS products. But in addition to these basic kind of line charts and series plots and graphs, we definitely delivered some solutions, similar solutions for pie charts, scatter plots, heat maps, and also totally branching off into a different realm. We've delivered a sonification solution for geographic maps, and very basics of it, but it uses a totally different frame of reference, not the Cartesian plane. But what I wanted to just show you here, the purpose of all this, is really just to give you a taste of some of the bread and butter audio mappings that are used across lots of sonification tools. What I showed you here is not unique in the sense that pitch is mapped to the y-axis, that's very common, and then pan is mapped to the stereo panning is mapped to the x-axis. So with that, let's do one more for fun, just here in the Cartesian plane, and let me hide my screen.
Temporary screen enable until next restart.
There we go, and I'll switch over here.
Group series block document. Button accelerate group series. Sample window. Items 7 100.html 717. Series block showing adjusted close by date Google Chrome. Series block showing adjusted close by date. Series block showing adjusted close by date. Accelerate series block showing adjusted close by date button. Graph view SAS graphics accelerate Google Chrome. Graph view SAS graph.
Okay, here we go. Let me get this back on.
Verbose off.
Turn my speech off.
Scan mode.
Okay, there we go. All right, so let's see. What speed do we need here? There's probably about let's see. I think there's about 250 data points. I'm going to speed this up pretty fast so you can get the gist of it. Another thing that we learned after teaching a lot of people with visual impairments or blindness how to use this, and also doing a lot of work with teachers of the visually impaired in K-12 to help them understand how to use this technology so they can teach their students. One of the things we learned is that it's pretty common for people with visual impairments to kind of get stuck in the weeds, and do the point by point. When there's hundreds of data points in a graph, that obviously doesn't scale. So pretty early on, I began kind of deliberately teaching students or users with visual impairments to scan the entire graph first to kind of get that glance exposure, to get the gist of the graph first, as opposed to trying to build up the whole from the parts, which is definitely the natural tendency for those of us with visual impairments. So if you think about reading Braille with your finger. Now, when you read Braille, it actually happens, you're supposed to do it with multiple fingers at once. There's a system for doing it. But, let's say you basically have a few fingers. You're basically reading one line at a time with multiple fingers. It's a very kind of a peephole optimization process. Whereas a sighted person might scan the entire page. Certainly that's how you guys do speed reading. It's really common for those of us with visual impairments just to kind of build up the whole from the parts. And what I think the more effective way to do this is to get a glance exposure of a data visualization and then go in and do, look at individual parts as needed based on interest and need. So to that end, I'm going to speed this up.
Slow. Normal. Fast.
To a faster speed so that we can show, we can quickly see this entire data set. Here we go. From left to right. Okay, and So this is your last rectangle. So draw your little rectangle on your piece of paper there. And I'll play this again at that fast speed. And then I'll play it 2 more times. Then I'll slow it down a little bit so you can maybe fill in the gaps. Okay, 1 more time at this speed. Okay, now let's slow it down.
Normal.
Okay, here we go. Same thing, slower speed. Okay, and 1 more time at a little bit of a slower speed.
Slow.
Okay. Let's reveal it.
Screen curtain disabled.
All right, this is the NASDAQ 100 for the last year. Okay, and on this one, I'm going to show you the actual graph.
CCDD. Series plot showing just close by date document.
All right, so you should be able to see the actual visual graph there now as well. And the moral of the story is that those of us with visual impairments, we deserve to be able to see the value of our 401ks go down just like everybody else can. You know, that is how I see this, or go up for that matter. In the last year, it's been going down, but you know, perhaps it's a great time to buy into the 401k. All right, let me stop sharing my screen, and I have a few more just comments, closing thoughts, and references that I wanted to share. And then maybe, Chris, we can open it up for Q&A. So just give me a moment here.
Sample 01, column 2. Script.docs word 1, column 3. Spotify premium 1, column 4. Zoom 1, column 5. Schedule VIS4DH 2020. Series plot showing just close by date. Sample 01, column 2. Script.docs word Spotify premium 1, Zoom 1, column 5. Zoom window. Return to meeting button.
Yeah.
Stop share. Alt plus S button. Zoom window. Schedule button.
All right.
Return to meeting button. Series plot showing just close by date document. Zoom 1, column 2. Samples 1, column 3. Meeting controls 1, column 4. Mute. Currently unmuted. Alt plus button.
All right.
Stop share. Alt plus S button.
All right, there we go. So now I should have stopped sharing, I think. Yeah. Okay. Give me just 1 minute to bring up my notes. All righty. One quick second here. All right. So we've seen some example, or probably an example of sonification, which is definitely an effective way to perceive some types of data visualization, given that sonification is very much in its infancy at this point. We briefly discussed the tactile mode of perception and tactile graphics, which have been used for well over 100 years. And is also an effective way, given the fact that it is at this point not interactive and does have a significantly less acuity, tactile acuity versus visual acuity. But that said, if we're going to make visualization inclusive for everyone, of course, much more research and, more importantly, collaboration is required. These technologies are certainly mature enough to be included into the mainstream as alternatives for those of us who cannot perceive visualization via the visual mode of perception. And I just wanted to close with that you guys have a tremendous opportunity to make visualization more inclusive for everyone moving forward. And I think IEEE is the place to do it, and the community to lead this charge. So with that, I want to just share a couple of references in case you're interested. I mentioned for tactile graphics, look at the BANA guidelines and standards. You can find that at brailleauthority.org. There are different groups working on refreshable braille displays that are kind of scattered. There's not a good single place to find that information. If you are interested in refreshable braille displays, I think a good person or a good group to contact who's kind of has their pulse on this is the National Braille Press in Boston, National Braille Press. And they have a Center for Braille Innovation, which is working with and talking to and collaborating with different groups who are working on refreshable tactile displays. When it comes to research on sonification, I think the best place to find research in that regard, one of the best places, is the International Conference on Auditory Display, ICAD. International Conference on Auditory Display. I've had the wonderful opportunity to attend one of those conferences several years ago. It's a wonderful research community, and I encourage you to reach out to that community and invite them to be included here at the premier conference on data visualization. And then lastly, if you would like to play with sonification, I recommend the Sonification Studio. Sonification Studio is a free online program. If you just Google Sonification Studio, you'll find it. It was created in collaboration between the Sonification Lab at Georgia Tech, which is run by Dr. Bruce Walker, a wonderful collaborator, and also HighCharts. HighCharts has incorporated sonification into their online graphs. And they together produced the Sonification Sandbox, which is a great place to go play with sonification if you're interested. If you're interested in connecting with me, I'm not actively working on sonification anymore. I've kind of moved on to just the broader field of software development as I pivoted towards GitHub. But I would be happy to bounce ideas off of each other with you, or maybe direct you towards someone who is actively working in the field at this point. And you can reach me on LinkedIn. If you go to LinkedIn and search for Ed Summers, SUMMERS, and GitHub, you will find me. That'll, of course, return my profile, and I encourage you to connect with me on LinkedIn and send me a message there if you have a question. That is the best place to connect with me. With that, Chris, let's do a time check and see if we have time for questions.
We still have a few minutes for Q&A, definitely.
Yeah. Thank you.
So thank you, Ed. That was wonderful. At this point, I'm going to kick everyone out of the room so I can have you to myself for conversation for 4 or 5 hours. That's the jealous side of me. But we do have a lot of questions coming in on Slido and from the audience. So I'm just going to ask a few from Slido. Also, for people in person, feel free to use the microphone at the center of the room. And Petra, I saw you had a few questions you could ask yourself on the microphone if you prefer. So the first question is there a need to, quote, calibrate the sonic scale for users, for instance, by playing the lowest and highest notes, or do you find that it works well even without that?
Yeah, I think there is a need for new users to do that calibration and to offer that. Yeah, for sure. I think as we use the technology more and more, I think we get dialed into the range, and it becomes less of a need. That is an excellent point. Yes.
Yeah. Okay. So another anonymous person from Slido said, "Thank you for this amazing keynote. Is there a place we can find the recommendations you listed in the beginning of your talk for the Viz community to be more inclusive, perhaps beyond the list of resources you mentioned at the end?"
Yeah. I've never actually wrote a simple guide to sonification. I think one of the best places to go start is the Sonification Handbook. It's more broad than what we talked about here, but it has a sample of just really solid, well-referenced research articles in the field of sonification. And also, by the way, prominent researchers in the field who you could go look at their additional publications.
Okay, thank you. Petra, would you like to ask your questions directly?
Yes,
Okay,
I can hear you.
good. Hi, I'm Petra Eisenberg from INRIA. My question was about whether some specific music listening skills are required to do well with sonification. So, because I clearly didn't.
You did not do well.
No.
Yeah, I think so. I think the more musical background you have, the better. There's a relatively low number of people who are actually tone deaf. Like you think it's more common. I don't know. I can't remember the numbers off the top of my head, but it's a relatively low number of people. So that's one point. Two, in my experience, this is anecdotal. We haven't published on this, but it is possible to improve those skills relatively rapidly. And during the training that I did with both students and teachers, we developed some exercises to help with that regard. So, for example, which pitch is higher? But of course, that is part of what you do in music training. So having that musical background is a definite advantage, but it's not absolutely required. So that's one thing. The second thing is what I did not show you is that our implementation of accessible data visualization at SAS included quite a bit of additional information that I didn't show you. So an automatically generated text description of each graph, which helps you quickly understand and systematically for every graph understand the range of each axis, the variables that are represented on each axis, and also the ability to download the data from the graph so that you can explore it using other means that you might that might be better suited for you.
A similar question from Anonymous. Do vision impaired people have to build up sonification literacy before deriving insights from audible charts? So for instance, is there a level of interpretation skill, not just perceptual skill that might be involved?
Absolutely. I think that one of the challenges we have as people with blindness, especially people who are blind since birth, is there's so much incidental visual information that provides just the basis of so much knowledge. If you go back to, I believe it might have been William Playfair who is credited with the first bar chart. Don't quote me on that. I'm shooting from the hip here, but hundreds of years ago, the first bar chart was created, and it came with what I recall as a very long explanation of what was actually represented. And people who are sighted through school and incidental exposure get a tremendous amount of benefit from all this incidental information and training. And those of us who are blind, there's such a visualization desert, particularly for those of us who are totally blind, that we don't get all that incidental information or very little training because of the cost of tactile graphics is so high. So yeah, there's definitely training that needs to happen. But in addition to that, I will say I've taken a keen interest in teaching people who are visually impaired and blind to learn how to use their hearing more effectively in general. So I'll give you an example. I've published a lot of blog posts and related material on being able to read with your ear very fast and to speed up the rate because I think it's a superpower that all students with visual impairment should learn early on. And I've collaborated with quite a few teachers of the visually impaired to get those ideas into practice. And another one is those of us who are blind, when we navigate the world, either using a cane or a guide dog, when we're totally blind, we do it completely by hearing and learning, systematically learning how to hear what's in the environment is a skill that some of us pick it up naturally, but other times it must be taught in the field of orientation and mobility is what that's called. There are practitioners there who are teaching specifically that skill, how to hear your environment better. So yes, it is true. There's just a collection of various problems there that must be overcome. And sonification is kind of at the tip of that iceberg. There's a bunch of fundamental skills that need to be learned before we, bear off into sonification of line charts and bar charts.
As a follow-up to that, you mentioned William Playfair, and there are some examples of people writing histories of visualization. Has anybody written some sort of history of sonification techniques?
I do not know. If I were to go to one person to ask that question, I would ask Bruce Walker at Georgia Tech.
Okay. Thank you.
Very interesting talk, thank you. So I'm Ali Sarbat from UMass Amherst. So I was wondering that you use like a piano sound. So, and I missed the beginning of the talk, I don't know if you mentioned anything about it, but what if you use like something like more continuous, like a violin, for example? How would that change? Would you map that to the type of the data, like a piano for discrete data, or like a violin for continuous data? Also, kind of a second question, can you combine those like an orchestra of sonification to communicate like, I don't know, more data? Thank you.
Yes, you can. Those are both excellent ideas. And if I had it to do over again, I think I would have started with more continuous sound, or at least included that in the very beginning, as opposed to just the discrete piano sounds. As you kind of dive deeper into sonification, there are lots of different possibilities for expressing variations in data, including what you just mentioned, as well as timbre, the tone of the data, the tone of the sound. The challenge, in my experience, though, is establishing the audio mappings of those different sound characteristics so that end users can, understand and understand what's being expressed using sound. And we deliberately chose to keep this implementation very, very simple to be able to kind of solve these problems for the simple, most used graphs types, and for the most part resisted the urge to bring in the entire orchestra. But it would be an incredibly fun place to play, and people have played. If you Google sonification, even go to the Wikipedia page for sonification, you can find examples that pull in all kinds of interesting audio mappings.
Okay, thank you.
Yeah.
Well, there are several more questions on Slido, but we will need to move on to the lab talks in a second here. I do want to wrap up with a kind of a big question. This is also from Petra. Are there any technologies of the future you're excited about?
Yeah, I think strictly from a data visualization perspective, I'm very excited about these refreshable tactile graphics displays. I think these modalities that we've discussed, they are not mutually exclusive. I think they can be used together to reinforce each other. And I mean, just as an example of that, I don't know if you noticed, but the stereo panning that I was using is also mapped temporally to the graph as I played it from left to right. Mm-hmm. So if you couldn't hear the stereo pan, the temporal organization of the sound, filled in for you, right? So I think as we look forward to a maturation and affordability of good refreshable tactile graphic displays that are affordable, and also 3D stereo sound, a maturation and affordability of that technology. These combined can create kind of a virtual reality type experience that adds quite a bit of richness to what we've done here, what I showed you here, which is really simple left-right panning.
Well, thank you for that. That actually speaks to all of the remaining questions that we have in Slido as well. So please, everyone, join me in thanking Ed for a really amazing keynote. And I do think that you've gone a long way today in achieving your purpose and raising understanding and at least for me, a lot of interest in trying to span these areas. So thank you very much. Yeah.
Thank you for the opportunity.
Okay, with this, we'll switch over to the two lab talks. Okay.
Hello, my name is Anna Foucault.
I have some slides first. Sorry, can we go to my computer first? Can we go to my slides first? Yeah, so I'm this one. Oh, yeah. Yeah. Hello, everyone. So I'm going to give a quick, brief introduction. What are lab talks? They are basically 5-minute lightning talks. They are for groups of people working at the intersection of visualization and DH, and is looking at the presentation of approaches, looking at the groups and specific projects. The goal is to highlight the relevant people that are activities in our field and to allow collaboration and exchange of ideas. So for the lab talk, these have been organized by Mark Jean and Xavier. Unfortunately, they can't be here, so they are joining us on hybrid. So if you could say hi to them on Discord or anything like that, that would be great. So if you go to our website, we have a list of labs that we've been collecting for the past several years. Feel free to have a look at them. And you can add or update your labs at this link here. So it's basically allowing collaboration between people. And so for those that are interested in statistics, there are multiple topics that we have covered going from cultural heritage to NLP. And since the founding of the year, since 2002 and all this thing, there's a number of labs that have been collected for this website. And there's also the lab numbers of people ranges from 1 to up to 99 people in the lab. So the location ranges from all over the world. And in our lab talk today, we have 2 sessions. The first one is now, where we have, the first is by Anna Foka from the Center of Digital Humanities in Uppsala, and the second one is by Doris Kominski and Visuality and Visualization Lab in the first session now. And then in the second session, we have 2 other labs. So can we go to the first lab talk, please? Which is by Anna Foka from the Center of Digital Humanities, Uppsala.
Hello, my name is Anna Foka, and I'm here to talk to you about the Center for Digital Humanities Uppsala. And I would like to thank the organizers for allowing me to do this in an asynchronic way. So, as I said, I am Associate Professor in Digital Humanities and the Director of the Center, together with Mats Lindström, who is our Deputy Director, and our excellent administrative team, which is composed by Kalle Berglund, our Research Coordinator, and Lilia La Monica, our Research Communication Officer. So, who are we? We are a center that started in 2021, and we have a 3-fold mission, namely research initiation, events, as well as supporting digital humanities projects, training, which means to develop and to support graduate and early career programs, and infrastructure, so resources and the technical know-how for research implementation. We are supporting and supported both internally but also by national and international cooperation, namely the Swedish Research Council's latest humanities infrastructure applications. One is HUMINFRA, which is a national infrastructure for digital humanities that we're part of, together with other centers in Sweden. InfraVis, which is the national infrastructure for scientific visualization, and also VIS4DH, which is the national infrastructure for Swedish digital archaeology, as well as other initiatives, for example, the Wallenberg AI and Transformative Technologies Education Development Program, as well as the European Open Science Cloud and other European Commission initiatives that we are part of. I say we, and it's not just the managers that are doing the boring work. There's also our research engineers, namely Ekta Vats, who is the AI methods expert, who is an expert in image analysis, Dan Wu, who's our digital research infrastructure engineer, Marie Duparmet, who is our text technologies research engineer, and Dalia Ortiz Pablo, who is our data scientist research engineer. as you can see, we're overpopulated by women, which is a very good thing, I suppose. Then we have Vasili Kitsumari and Linus Eriksson, that are the geographic information systems research engineers. Maria Webstead, who's working with natural language processing, and Matias Piqueras, who is the application expert for the supercomputing server, the supercomputing center at Uppsala University. I promised the organizers, or at least I seem to remember that, I promised to give a little snippet of visualization projects, and since we are only in our sort of primary school stage, as we've only been operating for a year, I would like to show a couple of snippets, but by no means please contact me or the center, and please have a look at our webpage to see additional information. I would like to talk a little bit about the sort of attribution study on Francis Brooks' 18th century libretto Mayan, which is led by Michaela Vance at the Department of English Language at Uppsala University. And this is a comparative stylometric analysis with the aim to understand if the changes made in the published version of the Brooks 18th century libretto Mayan were indeed made by her. And you see a dendrogram showing a stylometric cluster analysis of works by Brooke and other contemporary writers and their disputed works. Then you have Agnieszka Beckman's web scraping and draw networks of archives, which is the goal of the project, is to show the repartition of all the old Swedish manuscripts across national libraries and how they link to each other, scraped and analyzed. And the result consists in interactive graphs like this example on the right, and they show how manuscripts are linked with each other via metadata. Another project is the Digital Perigesis project, which is an attempt between us and several other colleagues across Europe. And that is a visualization of the 2nd century traveling guide to Greece. And for this, we've been working with sort of what the scholars have been thinking in terms of visualizing the text and creating a GIS application to visualize the text. But also quite interesting, we're planning to create even more dynamic visualizations by implementing NodeGoat, which we have just become partners of. I hope that these short snippets are give you a little bit of an idea of what we do. You're more than welcome to follow us on Twitter and contact us to join our mailing list and get our monthly newsletter, but also please visit our webpage for further information. I would like once again to thank the organizers for allowing me to be part of this, allowing us at the Center for Digital Humanities Uppsala, and I wish you a very exciting continuation of the event, of this exciting event. Thank you.
Okay, now
Hello,
we have
my name is Anna Foucault.
now we have the second lab, which is the Visuality and Visualization Lab by Doris Kominski.
Hello, I'd like to share the screen, just a minute. Oops. Can you see the screen? Yes?
Yes, yes.
Oh, thank you. Thank you. So I'm Doris Kosminski. I lead the lab VIS with my colleague Claudio Speranza. We are based at the Federal University of Rio de Janeiro School of Fine Arts. Lab VIS is an interdisciplinary research group devoted to information visualization and cultural aspects of visuality. We are focused on research through design and entanglements in the creative practice and processes. In this brief talk, I will present some of our visualization works. In Brazil, indigenous tribes are scattered throughout the country, but mainly concentrated in the north. The Brazilian 1988 Constitution regulated all indigenous territories. However, the lack of investment and surveillance opens up space for environmental crimes like
illegal hunting, gathering, and mining. Each dimension, such as invasion or illegal mining, is represented with a different color. The tag shows the name of the community and the integrity of the territory. Slave Voyages is a set of two sculptures that use data from the trade of enslaved Africans across the Atlantic Ocean between the 15th and 19th centuries. An estimated 12 million men, women, and children were forced from Africa to the Americas. The original project was transformed by each encounter with the materials, teachers, and other students. Beyond the huge number of people enslaved, the number of deaths on the travel was brutal. Brazil was one of the biggest importers of slaves and the last to abolish slavery, a stand that extends to the present. The data sculpture was exhibited twice in Rio de Janeiro. People were especially impressed when they realized that one bead represents 10,000 people. Network of Us is an interactive visualizations of the names of Brazilians. People were invited to type their first name. At the same time, a photo was taken. Then, in the midst of the maze of names that were projected, there was a plot of the visitors and a graph showing the frequency of his names from the 1930s onwards. The visualization of environmental Brazilian shores uses data collected by divers to indicate the health of different species in areas of coral reefs. Several sensors record the temperature, brightness, and pH of the seawater. We sought engagement with the use of illustrations. We see the relationship between the increase in water temperature in 2019 due to El Nino weather phenomenon and the following reduction in the number of colonies of coral reefs. It is a visualization that allows us to understand the impact of climate change and the entanglements between humans and non-humans. We have been working with data from our university too, creating visualizations about the profile of courses, students, and teachers. One of the most interesting results was clearly observed in the simple graph. The increase of Black and brown students enrolled at the university, which went from around 10% in 1993 to over 45% in the second half of 2019, thanks to the implementation of public policies. In this case, the visualization helps to disseminate the numbers to the traditional press. In the last 2 years, we've been involved in a big challenge, the visualization of newborn and maternal health related to air pollution. We employ secondary official data, which means unidentified heterogeneous data from over 5,000 municipalities combined with air pollution data. Last week, we presented the visualization, which is still in process, to technicians and decision makers from the public health sector. We are able to point out the influence of color, prenatal care, and the married conditions of the mother on the mother's and child's health. So, creating visualizations help us to review and recreate worlds. We are looking for collaboration, so let's talk, be in touch. Thank you. Oops.
So that concludes our session for this morning. So we have a break for lunch and we meet again at 2, is it? At 2 o'clock? At 2 o'clock with our keynote speaker, Miriam Posner. So yeah, thank you everyone.